Hi, everybody, and welcome to the Extreme Performance Series video blogs. We're happy to be back sharing some great performance information. And with me today, I have one of my peers that probably needs no introduction, Sudhir, who's one of our Oracle gurus here at the company. But for those that don't know you, Sudhir, give yourself a quick introduction.
So my name is Sudhir Balasubramanian. I'm a senior staff solution architect and the global Oracle lead for VMware. Essentially, I've been working with Oracle technologies for the last 25, 26 years. And so I'm primarily pre-sales, but I also get pulled into post-sales or let's say customer escalations or customer POCs, field-facing, customer-facing partners. So pretty much, a jack of all trades, if you will.
Wow. So besides all that introduction, I mean, your key phrase is Oracle, right? And so I know
Yes.
you're the guy who gets deep into the weeds there. So I hear you have some information to share with us today. And I think starting was what, vVols versus VMDKs, is that right?
Yes, that's right. There's always been this discussion, right? To RDM or not to RDM, right? To BMDK, not to BMDK. And there are always two sides to every discussion here, right? While with RDM, you do have that noisy neighbor elimination. And many people do claim that the performance is much better than BMDK, even though engineering has proved that the performance difference is very minimal, as you know that, Mark, right? And VMDKs, they do bring that flexibility, the ability to that table here, right? And so vVol is that perfect bridge, which essentially is an RDM at the end of the day, but gives you all that ability, the flexibility, the throttles, the levers to do pretty much what you want to do, right? For any business critical application, be that your database cloning, be that your database, your backup, your restores, and so on and so forth. And the one thing that customers have been asking or clamoring about is, of course, workload performance and so on and so forth. So this is a study. This is a test that we did when we ran our Oracle workloads on vVol versus VMFS, right? The storage in question was a pure storage flash array X50 with ESXi servers, Broadcom LPE 36,000 HBA. So we essentially had one VMDK on a separate PV-SCSI controller from the other, database component. Then the second test case was two VMDKs on two separate PV-SCSI controllers, right? And the ask of the day was, let's put that on vVol, let's put that on VMFS, run our workload, and look at the metrics from an ESXi perspective, from a guest operating system perspective, from an Oracle perspective, and see, has those metrics or KPIs improved, or is that something that we need to have a look at, right? So from a test bed perspective, we had this virtual machine, which was 20 vCPUs. We made sure that this virtual machine fitted within a NUMA node, so we don't cross NUMA boundaries, so you don't have the NUMA noise as a contributing factor. Our virtual machine memory was made to fit within a NUMA node's memory. The Oracle SGA was very deliberately kept to a minimum, 32 gigabytes, because we wanted to stress the IO, right? The physical IO, not the logical IOs. The operating system was OEL 8.6, UAK, latest and greatest Oracle binaries, 19.15. We use Oracle ASM. That way we want to make sure that the IOs, right, are as close to raw performance as possible. You must have heard me talk about SLOB, silly little Oracle benchmark. That's the load generator that I used. And the scale for the test was almost a terabyte. So almost a terabyte of data going into the test case one and also test case two. We see that the average physical SCSI device writes per second, or let's say the megabyte writes per second, that has increased, right, over the test what we do for vVol versus VMFS file system, right? And then if we start looking at the guest operating system, or if you start looking at an Oracle database or a workload perspective, right? The metric that I used here or that we used here was the number of sequels that one is able to execute in a second, right? And when we ran that test, we saw an increase of, let's say, 10,000 versus 9,000. The metrics increased or the metrics improved from an Oracle perspective, from a guest operating system perspective, from, let's say, the ESXi perspective. So we said, okay, that's great. That was a one VMDK test. What happens if we start increasing the number of VMDKs, right? Do we see that performance increase linearly, right? And so we had two VMDKs and we ran similar tests and we saw similar results. So case in point being, right, if one is looking for the flexibility and ability of a VMDK without the negativity of RDMs, vVol is a perfect example, right, for business critical application. And so anything to do with noisy neighbor elimination or anything to do with increasing performance, absolutely, one is able to get that.
Well, and see, I think that's really interesting because, a lot of people don't think about vVols. I think vVol adoption is something that's still growing or being considered out there. And this is, a great data set to show that we shouldn't be fearful of that. Again, performance is great or better than, continues to scale. And so, yeah, vVols is a solid architecture to run these Oracle databases on.
right? And this doesn't have to be the oracles of the world. It can also, it could also be the SQLs of the world or the RSAPs and MongoDBs and so on and so forth. But Oracle is just an example.
Well, I heard too that you were also tasked with an investigation where, we look at, I think it's important what the in-guest operating system is seeing and reporting as we look at kind of the IO stacks. And there were some kind of inconsistencies that had been reported on occasion. So I hear you've done some work in that space, Sudhir. Tell us about that.
When people used to use RDM, what used to happen is the page table that used to get reported from the underlying stack, from the underlying infrastructure storage stack, the maximum transfer length and the optimal transfer length, that used to get reported correctly. So for example, if you're running, let's say a pure storage, X50 in this case, the maximum IO size is 4 megabyte. So that's why if you see in the table on the right-hand side, right, the right-hand column, that's an RDM, right? And when we do the SGDPD column command, when we run the command, you see the maximum transfer length and the optimal transfer length is set to 8192 blocks, which means it's 4 megabyte, right? Unfortunately, what used to happen is we did not report correctly these two parameters for VMFS or for VMDK. So what used to happen is when we run the same command on VMDKs, you see them reported as 0 blocks or not reported, right? So that used to give customers a false sense of security, a false lull, saying, oh, you know what? It's either 0 block, which means I could then set a parameter called max sector KB. I could set that to whatever number I wish to set it to. I could set that to 0. I can set that to a default of 1280, which means if I don't do anything on 8.7, REL and OEL, it defaults to 1280 kilobyte, right? Or I could even set it to 32767, which is 32 megabytes. That's the maximum value as determined by the max hardware sector KB. So whatever the value of the max sector KB we set on the guest operating system, people used to think that, yes, I'm able to push IO workloads, or I'm able to push those workloads with an IO size as large as that number. But unfortunately, that wasn't the case, because at the end of the day, the bandwidth and the IO size is controlled by the underlying infrastructure, right? So what used to happen is, when we used to move from one storage platform to another storage platform, or you move from one guest operating system version, right? Let's say RHEL 7 to RHEL 8, or even from, let's say, RHEL to OEL, right? Those numbers used to be very inconsistent. So people used to get inconsistent performance. And one is to wonder as to why, even though I set the max sector KB, for example, to a number X, I still have this inconsistency, right? So what happened was we reached out to engineering and VMware engineering and our team, right? We worked on this, and I'm going to move on to the next slide, and I'm going to show what the fix is, right? So essentially, we ran a couple of tests here, right? So if you look at the chart on the top, we had 3 tests. We actually ran 3 tests, right? One was without the engineering fix, essentially leave the max sector KB, right, to the default of 1280, right? The second was leave it at a maximum, or set it to a maximum of 32 megabyte. And the third, based on the underlying storage architecture, based on the underlying storage vendor, Pure in this case, what happens is the max IO size of the storage platform is then bobbed up all the way to the guest operating system, and that is set correctly. So you had 3 tests, right? One with the default, one with the maximum, and one with a 4 megabyte. Essentially, again, the workload used here was LOB, Silly Little Oracle Benchmark. And if you look at this parameter called work unit, and that's on the left-hand side of the slide here, essentially, we set that to a minimum because we did not want to stress what's known as the Oracle redo or the Oracle archiving. We just wanted to push a lot of physical IOs, right? So with those 3 tests, right, if you look at the graph on the right-hand side, our physical writes blocks per second, our write IO requests per second, that reduced. What then happened is, remember the metric or the KPI that I spoke about in the last use case, right? The execute SQL per second. Well, that increased. The transaction per second increased, which means with a less amount of writing, with a lower amount of physical writes, with a lower amount of write IO per second, I'm able to push a lot more executes per second, and I'm able to push a lot more transactions per second. And I get that consistent performance across all of the test runs I've done, right? So, I mean, one could just wonder why, and looking at those execute SQL per second or transaction per second, one could argue and say, oh, you know what, you have 242K with the first test, you had 241K with the second test, and probably 243K with the third test, and they're all kind of coming very close to each other. So what's the point in setting these parameters, right? The point is, if you were to run these tests, you would get inconsistent results. It's not like you will get 242 or 241 every time. You might get lower numbers or higher numbers. But with the test that we did, we got consistent performance, and we are actually showing the correct IO size that the storage vendor or that the storage has with the guest operating system, so the guest operating system is able to take correct decisions when it pushes these workloads.
Well, and I think so. That's really important. Again, a little bit unfortunate that this was found through some investigation discovery, but optimally here, this does improve efficiency. It allows us to bubble up the correct vendor-specific information. And then again, we see the benefit, for the customer. So I think this is a great, not only discovery, but obviously an important fix. And if I'm correct, I think this is supposed to roll out in our 8.0U2 release. Is that right?
Yeah, that's correct.
Awesome. Well, as we've gone through this, we certainly see, some interesting use cases as we maybe look towards using vVols. We certainly see progress as we clean up some of our efficiency, optimize some of our efficiency there too. And, so the next question is going to be, Sudhir, where do we go for all this great information? Like, where's the spot to find anything Oracle related, anything that you might want to brain dump on the community?
All of the Oracle on vSphere, white papers, including Oracle on hybrid cloud, whether that's vVol, whether that's vSAN, best practices, deployment guide, workload characterization guide, technical document, KV articles, blogs, pretty much everything finds this home on the Oracle on VMware one-stop shop. The link is there at the bottom of the slide, but that's pretty much where, our team, essentially me, I dump everything up there. So if you're looking for any Oracle licensing collaterals, you're looking for Oracle on vVol, Oracle on vSAN, Oracle with PBRDMA, or with NVMe over Fabric, any such guides, pretty much that's the place, the one-stop shop where you can find those collaterals.
Well, that's awesome, Sudhir. Thanks for maintaining that for us. Thanks for joining us today. And look forward to everybody joining us for our next Extreme Performance Series video blog edition coming soon.